All right, welcome everyone. Thanks for being here, for attending Nordic APIs. I'm David. I'm the CTO at a company called Axiomatics. We're based here in Stockholm, Sweden. Not that I need to say it's Sweden, because you're all in Stockholm, so you should know this. I'm joined by Jonas, who's from Curity, who used to be at Axiomatics. So we worked together for 8 years, 10 years, roughly.
Something like that, yeah.
Yeah, until I kicked him out. It was too much.
And I landed here.
You what?
And I landed here at Curity.
And you landed at Curity, yeah. So today what we're going to do is show you how very quickly, we're going to try to do very little slides. We're going to show you how you can go from a naked API, an unprotected API, and actually secure it, do authentication, do authorization, the whole shebang. And the analogy we're using, because we're in Sweden, is very unstereotypically meatballs, right? So next slide. I'm going to cook up some meatballs for you guys. I forgot to bring my hat, I'm sorry. But I'm very good at doing meatballs. So the first thing I want to do is put that API in place. Next slide. So you have your client, your computer on the left-hand side. You have your API in the back end. There's nothing else, right? You're just hitting that server, whatever API technology you're using, Spring or whatever it may be. You're just hitting it. And that's just your API, unsecured, unauthenticated, unprotected, open to the whole wide world. And that's not great. So what I really want to do is I want to make that API secure or safe. So the very first thing I'm going to do is apply an API gateway. For those of you who saw Josh's keynote this morning, you could use Zuplo as an example of a gateway. You put that in front of the API, and that's going to give you basic things like traffic throttling. Back in the day, we would have talked about SQL injection through API. It could be content injection. Lots of things you want to protect your API from. If you go to OWASP, they have 2 top 10 lists, a general top 10 security threat list, and then a specific API security threat list that you can look at, and there's many different ways you can actually attack an API. So the gateway is going to be there to take the brunt of the work for you, but gateways do not do authentication. They don't typically do authentication. They don't typically do authorization, right?
I would say they can sometimes do it, but they don't do it particularly well.
Exactly. So what are we going to do next? The next thing is, I've got my kitchen. I've made it a safe place. I've got my fire blanket. I know I'm not going to cut myself with a knife, hopefully, or grind my arm through the meatball grinder. Who knows? But now I really want to know who that customer is, right? Because I want to charge them. I want to talk to them with their first name, for instance, and that's where authentication comes in.
Yeah, exactly. There's a lot of different ways of doing authentication there, obviously. It depends on who the client is or what's operating as the client, right? It could be another API that's going through this, but it could also be users. So users, we need to authenticate in a different way. SAML, OAuth, OpenID Connect will mostly use OAuth and OpenID Connect here today. In our demo a little bit later.
Wait, what? No SAML? Really?
No SAML.
I'm
SAML is dead. Everybody's knows that.
Yeah, SAML died. But yeah, it's worth mentioning that these are standards, right? But there's other non-standard ways of doing authentication, and there's also more basic ways that we had in the past. Like if you go back to HTTP and HTTP basic auth, these were all ways of doing authentication. Of course, the newer technologies, OAuth and OpenID, they open up a whole other world of possibility. And like what you said, Jonas, is interesting. We're dealing with different kind of identities, right? It could be end consumers, it could be machine identities, it could be another API on behalf of a consumer. So you have to think about all those options when you're authenticating so that you know who you're really dealing with.
And so this is, it's actually a snippet from the live demo that we're going to do later. But in this case, we're calling an API here trying to get a record. And in this case, we don't have an access token as part of the request, meaning we get a response that's you're unauthorized. It's missing, or there's an invalid token in this case in the error message. But if we don't have a token, we don't get access. It's pretty much that simple, right?
Correct. In the demo, we have 2 paths. We have an unprotected path. We're using Kong API Gateway, but what we're saying applies to pretty much any API gateway. So this path here is the protected one. When we go through the protected one, we have a policy that states, is there a token, right? And is the token valid? We don't have one for one. Had we used the unprotected path, you would have had access to the data.
We'll get to the depths of it because there's more policy than this, but this is like the coarse-grained authorization, right? You need the first thing is you need a token, otherwise you're not going to get access. We can look at more things in the token and determine how much access you should get. But the first thing is, if there's no token, you don't get access. Or if it's expired, even, you don't get access either, right?
So then,
yeah, if we do send a token, it's actually hard to see from that screenshot, but down here, you can see it. There is a token down there. If we do have a token, we do get access. We're going to look deeper into what the policies are that actually allows this access, but from a course grain perspective, yeah, now you get access. You have a valid token.
Isn't there a typo there, though? Like right there?
In the token?
Yeah.
Yeah, it should be a C instead of a D there.
Yeah. All right, so now that we know who the customer is, maybe we want to, dish up a special plate or give him, Moore's famous Lingonberry sauce, or, in the airline industry, it would be, are you a gold customer? You can go through the priority line, or are you a silver customer? So we need to know, when we know who you are, we need to know what it is you can do, right? It's not an all or nothing. As a matter of fact, oftentimes, in at least the world I live in, a lot of customers, they're like, oh, we've authenticated you. Boom, have at it. Go to the dessert buffet. Eat all you can. Well, no, we really want to determine what you can do under what circumstances. It's more, Jonas used the expression coarse-grained authorization. Now we're entering the realm of fine-grained authorization and exactly determining what it is you can do. And that's where authorization kicks in, which is the world where, Jonas used to live.
Where you live.
Yeah. I did leave authorization for a few years to go to authentication, and it was too hard for me. I went back to authorization. But there's a few standards that exist there. There's, of course, the oldest, possibly one of the oldest standards out there in terms of authorization is ZACWL. Dates back to 2001. It is SAML's sibling in a way. They both stem from Oasis, from that whole period of web services and SOA architecture, so on and so forth. The principle of ZACWL are still standing today. They're still very good. The syntax, if you like XML, amazing. If you don't, then not so much. Since we've evolved, we in the community came up with Alpha, the abbreviated language for authorization. That's what we're using today. But we also had Open Policy Agent back in 2015, roughly, came out with their own language called Rego. What's interesting, I don't know, Anders, if you're going to talk about the differences between the two, but Rego is much broader. It's a full-blown programming language. It can do everything and anything under the sun, which is both good and bad. Alpha is way more constrained. You can only really do authorization, right? And then beyond that, there's things like authzen that I've been working on for the past year, part of OpenID. It's about standardizing the PEP PDP request so that, if you had an API gateway and if you wanted to talk to Styra or Open Policy Agent or Signal or Axiomatics, you can do that using authzen, and it's going to be all compatible, right? And then, and then OpenRego, already mentioned it. Okay. But doing authentication authorization it's fine, it's great, now you're secure, but you also want to prove it. And that's actually a step that my customers kind of forget about oftentimes. I don't know if it's the same with you at Curity, but you've put out all these security mechanisms into place, and you generate logs by just using the product, but you don't analyze your logs. Well, you should, right? And so this is what this picture is showing, where you have your authentication layer over there, the key, and then your access control layer. They produce logs. You should actually centralize those. Put them in a place like a Splunk or a SIEM tool so that you can analyze your logs and understand things like, has a user been trying to authenticate for 100 times in the past 30 seconds and been failing at authentication? Because that could be an indication of an attack. Same thing for authorization. We know we're dealing with Alice, but they've been trying to look at a medical record at 3 a.m. for the past 5 minutes, and they're getting access denied. So your security works, that's fine, but the fact that you have that type of traffic, you should be like, maybe someone stole Alice's token, and maybe she's being attacked. So do look at those audit logs as well, right?
And this is also where, externalizing that authorization from the API in itself, because all of what we've done here could be done in the API, technically, right? You don't actually need the gateway. But externalizing this to something else means you have something else, the policy engine, to look at for who should have what type of access, right? Rather than looking in the code of the API where you, back in the day, would have actually built this capability in, which is really hard then if you have 50 APIs or 100 APIs, right?
Yeah, the fundamental thing is, and I took it for granted, but you want to decouple these security capabilities from the actual API for scale reasons, for visibility reasons, for maintenance reasons, right? Would you ever dream today of implementing a username password database in your app? Hopefully, no, right? You're going to use an identity provider, right? Well, it's the same thing with authorization. You should not be thinking of writing Python code or Ruby code or Java code saying, if this and that, then this, right? You should actually externalize it, decouple it, and put it inside of an authorization engine, and then you get all the other benefits of visibility and auditability. So here's the final flow. Customer orders meatballs, so that gets translated, as we all know, into an API call. That's how it works in a kitchen, right? We're going to go authenticate the user, do the typical OAuth flow, depending on the type of integration. It could be one of different OAuth flows, get an access token back. And then we call the PDP with the access token, with the data about the API call. So here we'd say, given token so-and-so, can that user do get/kitchen/shutbudar? And then if it is permitted, you send the call to the backend. The authorization engine, because it runs a policy language, it runs, in this case, alpha, but again, it could run open policy agent, Rego. Because it uses a policy language, you can use any number of parameters or attributes to describe what it is you want to have happen. So the policy could be something like, oh, a gold customer can order the extra large size meatballs. Or it could be a platinum customer can have a second helping of the Lingonberry sauce, that sort of stuff. You could decide. And the policies could be negative policies, or they could be positive policies. You could think about crazy things like, oh, if I check the customer's medical record and I see they have diabetes, I'm going to give them the vegan version of the meatballs, right? Now that's, of course, a slight sort of breach of medical record privacy, but you could imagine these types of scenarios. Any attribute is game. Any attribute can be used in a policy. So long as you know where to fetch it from and you can attest that the value of the attribute is trustworthy, you can use that attribute. And we got a meatball.
Right. So let's take a look at what this actually look like in a demo. I love it how you said we weren't going to do any slides, and we're on slide 15 right now. But
yeah, but in like 5 minutes or...
Yeah. I'd have to do this. So we got OAuth tools here. It's like your postman for running OAuth and OpenID Connect flows. It just helps in terms of obtaining tokens and calling APIs using them. So what we're going to do first is we're actually going to just call our records API here straight up. It's actually on the unprotected path, so we can just get all the data. What the data says here doesn't really matter. We have a couple of records. It's got an ID, a department, an owner. This is somewhat important, actually, in the end, because it's what the policy says. The policy says that a user that is a manager can get access to anything.
Correct.
Or a user that has any other role can get access to records that they own. So it's a relational aspect of the policy. Or you can get access to records to the department that you're assigned to, right? So if the record department and the user's department are the same, you also get access.
And you might have heard the term REBAC, relationship-based access control. This is an example of REBAC. Indirect relationship through the department and direct relationship through ownership. So you can do that in the policy language.
So that was getting all the records. We can obviously here query and get just one single record, 1, 2, 3, which is what we're going to look at here. So if we now try to, we can do 1, 2, 3 here. If we now call the protected path, what's going to happen? We have no token here. We actually saw a screenshot of this before. You get unauthorized because we need a token to begin with, right? So let's get a token.
The API gateway policy says two things. Number one, verify the token, and number two, do the access control check. Because we don't have a token, it fails on the first step. It doesn't even do an authorization check. It just says no token, you go out.
So now let's get a token. We are going to be Bob. Bless you. We got a couple of tokens here. We're just going to use this access token now to call this protected API. What's going to happen? We're going to get access. We did get access. Why did we get access? Bob, you guys don't know this. Bob is not a manager. I actually don't really remember the data at all. But look, Bob is not a manager. Alice is a manager. I think Bob is in the sales department. That's why we get access to record 1, 2, 3, because Bob's department is the same as the record department. If we do 1, 2, 4, we also get access because Bob is the owner of this record, right? If we do 1, 2, 5, we don't get access because 1, 2, 5
is
owned by Carol, and it's assigned to the engineering department, so Bob doesn't get access to it. What actually happens in the background here now, if we go back in here, I think we have some slides on this, don't we?
Well, you know, more slides.
Exactly. What actually happens in the background here is that we have all these abbreviations. You love the abbreviations.
You can
right?
go to the next slide. We got the product pictures. There we go.
Yeah, but I want to talk about these. So the enforcement point is something that runs on the gateway. In this instance, it's Kong, but it can be pretty much any gateway can handle this. A bunch of them have components out of the box, or you might have to have some plug-in on them. That's the enforcement point that picks this up, right? It calls the PDP. But it does more than that in this instance. It actually also takes our access token there, and it calls in this case, Curity. It basically introspects that token and gets a jaunt back that contains a bunch of these claims. The claims that are in there is, oh, it's Bob, it's his department, and it's his role, right? And then that jaunt gets passed over to the PDP, which is Axiomatics, that kind of parses that jaunt. So we have like securely transferred all these like attributes that we trust now to the PDP for the user. In addition to that, the PDP also calls a policy information point, because we'd only know here the user's attributes and we know the record ID, but we don't know the record department and the record owner. That's what the PIP here resolves at runtime. Then the PDP returns the decision back to the gateway, which is where the PEP lives, right? And you get a permit or a deny decision, which then this plugin on, in this case, Kong, takes over and says, okay, I'm allowing this record to be returned. There could be more than that, though, too. We could do more authorization on the gateway, right? Because it could be that the policy says, yeah, you can have access to record 1, 2, 3, but you cannot have access to the department field of it or something like that, right? So there could be even further fine-grained authorization in what the gateway returns.
And there's dessert. Who wants dessert? Anyone? Keep going.
Yep.
Oh, yeah. My daughter is really scared of the Cookie Monster, not because he's big, but because he eats her cookies. So like Jonas said, there's more things we could do, right? We could do batch authorization decisions on the way in. So you could say, oh, can user view record 1, 2, 3? Yes. Can user view parts 1, 2, 3 of that record? On the way in, you could do that. But you could also do it on the way back. Because on the way back, you actually know what the record is made of. You get a JSON payload from your backend API, and you realize that there's field 1, field 2, and field 3, and then you could trigger another authorization flow on the way back saying, okay, now that the user is about to get access to record 1, 2, 3, tell me which fields they can get access to. And then depending on the API gateway you're dealing with, you could use it to redact or modify the message. Not all API gateways can do that. Most of them can. AWS API Gateway is one of the ones that can't by design. They just want it to be super lean, so they don't look at the payload at all. But that's the sort of stuff you can do. And it makes for way better authorization. So it opens up many, many more use cases. And that is it for us. Thank you.